Alrighty then, where we are with maximum number of balloons. Okay, let's take a look at that. What does this has to say? Given a string text, you want to use characters of text to form as many instances of a balloon as possible. Okay, instances of balloon as possible. You can use each character in text at most once. Okay. Return the maximum number of instances that can be formed. Okay, I think again I would have to create a counter default text, say counter and okay, I have to and okay, so counter I'll have a default text of type int, right? Then I'll go for C in text, go counter of C plus equals 1, right? Generate the count. Now each okay, so balloon, right? Balloon, okay. So I have to okay, how can I define that I have okay, define maximum number of balloons. Okay, counter we have okay on the balloon, right? Okay, let me just print the count. That's right. Let me see how. I'll just return 0 for now. Syntax error. Oh, sorry, my bad. Okay, N1, L2. Okay, so the maximum number would be the minimum number of, let's say, balloon. Uh, counter generate the count syntax. Okay, and I want balloon. Let's define a default. Let me go counter. Okay, so I think I'll define a custom. I'll have say B0, right? A B0 A0 balloon 0 BL. I need a O. I need a O. I need a O of let's say 0, and then I need okay, so I need 2 L's and 2 O's. Okay. So B A double L double O. Okay. And I have O. Okay, B A L O N. Okay. 0. Okay, so I'll go for scene text. Uh, go if C in counter, then we'll go counter of C plus equals 1. Let me go ahead and print this. Okay, so it will be B1A1, right? Okay, so I need two L's, two N's. Yeah, but output is 1. Okay, bulb. Okay, so I need L and N to be power of n, and I need these to be n, right? Okay, say I need L comma O to be 2n and B A and n to be n times for n occurrences of balloon. Okay, so can I check that? Right. I'll go ahead 2n on this and on this, right? I need L and O to be 2n and 2n times for n occurrences of balloon. Okay, so let's so soon so I can go I know that I need L and O to be 2n times and B and O to be n times for n occurrences of balloon. Then I have okay, so then I have I need L to be 2n, B and to be n times for n occurrences of balloon, right? N occurrences of balloon. Then I can check so well B can go singles is equals okay, so B A and N should be equal. Else okay, if values of B and A are equal, right? If B and A are equal, then we'll get that value, and if not, then we will get the minimum of okay, so I can get the minimum. Okay, min of counter of B counter min of counter of B n and counter of L. Okay, so let me print singles, then I should get 1 singles min. Okay, not supported between instances of dict and int. I'm not storing int. Min counter. Okay, how does the min function in Python? Okay, 5 comma 10. Okay, n comma iterable. Huh. Okay, now the min function returns the worst value between right, and it throws an error It throws an error. What? Comma. Doesn't. Isn't this value an integer? Not suppose between instances of ticked and int. Type error is not defined. What if I cast it to int? Int. And then we have int. But we don't cast it like I don't remember how the cast. Okay, goes int and then this, right? Int and then this. We have int and oh, okay, that okay. So I didn't need to do all of that. It was just I forgot this thing. I think that is it. Uh, NL. Let's try. Okay, no errors, and I get singles then. Right, then I'll go doubles equals min of counter of sorry, L should not be here, there should be a A. Okay. Then counter of L and counter of, let's see, count 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 okay, count, then I have count, then I have count, then I have count, and then I have count of, okay, O, right? I need O, and let's print doubles, right? Right, doubles 2. Okay, so if there's some uh, 2 and 1, okay, I can go add 2 mod, right? If it is 2, it will be 1. Okay, so let me go. I have 2 and then 4. No, but it yeah, okay, BA, like 2 and 4, and for the last example it should be 0 and 1. Okay, so okay, I have to make sure that this should be greater than 1, right? This value should be greater than 1, and this value should be a multiple of 2. Okay, so uh, no, but okay, so right now I have to convert the values such that n plus 2n equals 1, right? So we can, with a little of bit of math, 3n, so n equals 1 by 3. Okay, so n equals 1 by 3, so 3n okay, so 3 3n equals 1. What does that tell me? Okay, that the if the sum is divisible, okay, if the sum is completely divisible by 3, that many occurrences we get, right? Okay, if singles plus doubles mod 3 equals 0, then I can simply return singles plus double doubles singles plus doubles divided by 3, right? I return this singles plus doubles divisible by 3, else return 0. Return 0. Okay, let's try this. hmm. Okay, 1 plus 3 mod 3. Okay, so single should be 1, double should be 2, 1 plus 2. Oh, precedence. My guy, precedence. Yes. Okay. That is on me. Okay. Okay, still 1.0 integer of this. Okay. Hmm. Okay, and if I try and submit it, wrong answer. Balloon. Oh, because I don't take into account that each. Okay, I assumed that the. Okay, so I assumed that each occurrences is greater than 1. Okay, so I have to make sure that if um, okay, if keys, if count of all the keys, right, if value of all the keys is greater than 1. Okay, because if I even miss one, then it's case over, right? So we'll check for uh, for C, for say key and count if count of k is less than 1, is less than 1. If count of k equals 0, then we return a 0, right? So if it is 0, we return a 0. Count key count of k equals 0. Okay, so I should also have a condition. So I need to if an occurrence is a balloon. Okay, then I find singles, 1, doubles, 2, right? There should be 1. Okay, let's try this. Balloon. Okay, expected 1, I got 0. Okay, how does that work? Right. Okay, so I want the minimum value. Okay, so singles, I think let's use this test case. Let's run this. What do I right? Output is 0. Okay, so 1 2 3 4. Let me print print count. Let's run this. Okay, I have 12 and then I have 10, right? Okay, so I really need to convert this into n and 2n. Right, this means one occurrence. Okay, so I think I loop through the I subtract 1 uh, okay, see, I have this dictionary, right? Like, so I have this dictionary. I can check okay, so I can check I subtract 1 subtract 1 from B A N and subtract 2 from L and O. Okay, right, we subtract 1 from B and A, we subtract 2 from L O, so we increment if at any point the number, I guess, right, subtract 1 from and subtract 2 from L and O. Okay, increment occurrence by 1, right? Let's try this. Okay, so I generate the count. I don't need to check this. Okay, okay, let's leave this. Let's comment this out too. Okay, so I generate the count, right? I have this. Okay, I'll go make a variable for counting the occurrences, right? So okay, so I'll go occur equals 0. then for then I'll it would be if else ladder. Okay. Okay, if any point the value of any of the variable is 0, we return 0, right? Okay, so for C in count, let's say for key in count, first check okay, first check if uh, the value is 0 or not. Okay, if let's say count of k is less than equal to 0, then we return whatever current occurrence is here, right? Else we go if count of k equals b, or okay, count of k, or it is a, or if the key is n, b-a-n, then we decrease 1 from the key. Okay, so we'll go count key minus equals 1. Okay, then we'll check else if count of key equals let's say we have L, or count of key is L and then O. Sorry, count of key equals O. Okay, first check first we check if they are greater than 2, right? Else return the occurrences. Okay. If sorry, I shouldn't check, it should be key, or key. Same here, I should compare the key, not the value, compare the key. Okay. Then if count of k is less than 2, then we can simply return okay, or else we can simply get count of k minus equals 2. Alright, and then here after both the conditions are fulfilled, right, go if key is less than equal to 0, then we return occurrence. I go okay plus equals 1, increment the occurrence, okay. And even at the last I'll return occur, okay. But let's try. Okay, it returned 5. Okay, so I should, okay, so if k equals this is this, then we get this. And if k equals L or k equals, okay, right, okay, 0, so this one was right, okay. So what is wrong with my logic? If k of count is less than or equal to 0, then we get occur. Okay, if it is not 0, then we go. If key is, then we decrement. Okay, but yeah, key equals b, k or a, then I should decrement 1 from all, right? Okay, okay. So we'll go through the loop. Okay, so I want to decrease 1 from all these and then 2 from all these, right? So I want to declare, I want to, okay, so I want to declare, so I want to delete 1 from k, b, a, n, regardless of the key, right? Okay. And then I want to, so maybe I can just I'll go with while true. Okay, fine, true. Okay, true. I don't care about the value, right? Okay, okay. Maybe I should make it. This is this is try 1. And this is try 2. Okay, so so I will create say try right. So okay, so I'll start a loop and then I'll keep subtracting the values. Then I'll check if any of the value is if we add 1 to occur. Okay, so occur equals 0. So while true. Okay, so decrement 1 from b, a, and n. count of p minus equals 1, and then count of a minus equals 1, then count of count of n minus equals 1. Okay. Yeah. Okay. Then we decrement 2 from L and O. Right. Decrement 2 from L and O. So count of L minus equals 2, and count of O minus equals 2. Okay. Then we check if all values are greater than 0. Okay, because if it was 1 before, it should be greater than 0. Okay, so for k in count, if count of k is less than 0, then we simply return occur. Okay. Sorry. Or else we go, if not, then we simply increment the count. Okay, so okay, plus equals 1. Okay, let's try this. And right, okay, 3 milliseconds. Okay, so this worked for me, right? So I created a count, then I just used this thing for one occurrence of balloon. E2 to be 1 for one occurrence of balloon. Okay, so you count, check, right? Okay. A second, and okay, so let's see how would okay, so let's see the solution.
Hey guys, Greg here. Let's solve maximum number of balloons, LeetCode number 1189. So we're given a string text, and we want to use the characters of text to form as many instances of the word balloon as is possible. And you can use each character in the text at most once. So we need to return the maximum number of balloon instances that can be formed. So in this example, we're given Nalay Bolko, and so in the red here, they have highlighted all of the relevant letters, the ones that would be useful for making balloon. So to make balloon, we need a B, we would need an A, we would need 2 L's, we need 2 O's, and we need an N. So we clearly have all of those letters, so we can make one of those. Now in this example, we actually...
I think my solution is O of n square. It will say O of n square. Pretty sure O of n, okay, right. Okay, because it just linearly goes through. Okay. just check. Right. Reference solution.
Can make two balloons, so that's why we have the reds and the green. Basically, you could make a red balloon and a green balloon. So the point here is that to make multiple copies of balloon, you would need duplicate letters. So we would need two B's, and then we would need two A's, and so on. And it's also possible that you can't make any balloons here. We have some of the letters, like we have an L, we have an O, but that's clearly not enough, and so that's just 0. Also, an important constraint here, we can see text consists only of lowercase English letters. Okay, so let's suppose we are given this example. How many balloons can we make? Well, we see from...
Okay, so one optimization that I can make is if at the end of the loop, if okay, and if at the beginning, if any of the value is less than or 0, then I don't even need to do this, right? So let's see. And this is an optimization that we check the starting balance. Okay, so this check needs to happen. Okay, right. Okay, so this okay, I can also make it a linear. Okay, but this is programmatically more sense.
From observation, we have a B, an A, an L, an L, an O, and O, and a N. And so that definitely makes balloon, and we would not be able to make more than one, so we'd return 1 here. We're basically concerned with the number of B's, A's, L's, O's, and N's that we have here. So we're going to make a hash map or a counter, or A's, L's, and so on. The N, that is actually a letter we are concerned with. And so since it is not in our hash map already, we'll put that in our hash map, and we are going to the letter we're concerned with. The A, same thing for that, because that's not very helpful to us. That is our second O, and so we have this. Very, very fast. Okay. For N's, we only need one of those two of the other letters. For L's here, well, we actually require 2 of those. We would actually need 4 L's to make 2. Is that the left of the other ones? How much it is contributing to the number of balloons we can get. So if we have one N, well, that's only allowing us 1 balloon. That is only going to allow us 1 balloon. Same with A, same with B, and O, we have 2 of them, so we are allowed that. And we would actually be constrained by the minimum of any of these. Because say, for example, we actually had like 12 L's here. Okay, so say we had 12 L's. Well, that would allow us to make 6 balloons. So this could make 6, except that's not going to help us because we still need the other ones here. So these are all of the potential balloons that we could make, assuming that all of the other characters are available, but we are going to be stuck by the minimum of all of these things here. Okay, so for this example, they all happen to be 1s, but we are constrained by the smallest number of balloons that a letter can make. Okay, so let's add a few extra letters here. Let's say that we also had another A, we had another L. Up, we're actually going to have 2 A's, we are going to have 2 B's, 3 O's, 3 L's. 1 N, that allows us to make 1. 3 L's. Well, that's not quite enough to make 2 balloons because we need 4. So we can actually get the number it can make as an integer division over 2. So 3 integer division over 2, that's 1.5. That runs down to still 1 balloon that we can make here. So this still only allows us to make 1. Here we make 2. Here we can make 2. And this guy again follows the integer division over 2 rule because we need 2 O's. 3 is only going to help us make 1. We are still constrained by basically the worst bottleneck here. And so the minimum of these things, the minimum value is going to be any of these 1s. And so again, the return would be 1. So let's code this up. Okay, so we're going to get predict variable string if C counter at C to go up by 1. So what this thing is still a already value associated with that increment. So we count it comes up in balloon. We go for each character in balloon. So all of the balloon characters, so all of B, A, L, L, O, O, and N, it actually does, are not. In that case, there's no way we can make any occurrences of balloon. Otherwise, we actually have a count of every single letter. So we need to return the minimum and at B, so the occurrences of two L's, and so you do integer division by 2 here to
Okay.
require 2 L's. We'll replace that with an O. We need 2 O's as
Okay,
well.
so that
And
is
the last
integer
letter
division.
counter at the character of N here. Okay.
All
L's
right.
over 2 code, and if we submit that, that will work. Okay, so let's talk about the time and space
Okay,
complexity.
so that is the way. All right. So let me quickly copy this. All right. So I'll create say main.py. Okay, my solution for LeetCode 1189. Maximum number of balloons. Okay. Right. Fit right. Okay. Okay. Fine. Okay. So this is mine. Okay. Then this is my solution. Then we will go with algo.py. This solution from algo maps.io. Algo map.io. Okay. So we'll start here. We have declared let's say count equals default text, it stores int, and I'd say balloon equals balloon. I can even give BALON balloon. Okay, so we'll go for CN text, right? The text FCN balloon, only then will be increment the counter, right? C plus equals 1. Okay. Then I want to return minimum of, say, count of B, right, comma count of A, comma count of will be a n, then count of L divided by 2, which is okay. So this is called integer division and floors the value to a division and converts the value to an int after division. Okay. Then we have count of O, because we need 2 of these. Okay, so let's run that. Okay, however, there was also a case. Okay, right. FC and balloon. Okay, there was one more case that I'm forgetting. Right, if C not in counter for C and balloon. C. Okay, if any, I don't understand this line. If any C not in counter for C in balloon. Okay, so Now we check if any of the character exists in okay, no, what is it, sorry, if any C not in counter for C in below, count if any C, okay, I don't understand this part. Hmm. Okay, but yeah, that would be on optimization. Yeah, I was working with minimum, but I didn't really get how I could do it with minimum. Okay, my solution. So let me go ahead and copy it. Solution from I have a function called max number of balloons. It takes a text. Okay. We got max number of balloons. Okay. Optimization. If the character in text are not uh, in balloon. No. If the characters in the text doesn't doesn't okay, hold up, I'm confused with this line.
To do a really cool Python function that comes up every now and then. If we have any of the C not in the counter for C in balloon, we go for each character in balloon. So all of the balloon characters, so all of B, A, L, L, O, O, and N. It actually does L and O twice, which isn't really necessary, but that's fine. If any of those balloon characters are not in the counter, well, that means we don't have any occurrences of a required letter. And
okay, so if we don't have any occurrences of the required letter, then we simply exit, simply return 0. So if any C not in counter for C in balloon, then we can return 0. Else we return this. Okay. Minimum of this. Okay.
And so in that case of B, 2 replace of A's, we have, okay, so that is actually our code. And if we submit that complexity, well, at least a big O of N. Fine. And we're also using a hash map. And so that is going to be a constant lookup there. So that's all. say if any of the basically the balloon characters aren't in the counter, well, that is looking up in the counter, so that's a hash map O of 1 solution, and iterating through the balloon characters, well, there's not many balloon characters, so that's fine. And this thing here, this is just a bunch of lookups into the dictionary, so that is also going to be, these are going to be constant lookups here. And the space complexity here, this is actually a little bit confusing here. We are storing space, however, we're forcing it to only store space for the balloon characters. So we're actually only using B, A, L, O, and N. That is only using 5 different spots in our dictionary. That is not much storing at all. And so that is actually going to be an O of 1 solution because of that. So I hope this was helpful, guys. Drop a like.
Okay. Got it. Let's try to run it. Runtime error if counter is not defined. Yeah, sorry. This is count. Okay. Then we got all of them. Right. Great. Okay. So that is it for today. Alright.